a new class of reactions for us is these oxidation reduction reactions, and they're really common. It's like whenever anything burns, what's going on inside your body with cells or metabolism, common things like rust. These oxidation reduction reactions are everywhere. But what drives them is the transfer of electrons between one reactant to the other reactant. That's what drives them. So what we are going to do is keep track of these electrons, do some electron bookkeeping by assigning every single atom in each reactant an oxidation state and observing and keeping track of how those oxidation states change. And that's kind of the big picture, because we'll be using those oxidation states then to balance reactions instead of just randomly, starting here or there, and there'll be a method to the madness. But here's an example of an oxidation reduction reaction. Here it is. See, the copper gets all tarnished unless you really heat it up. It gets all shiny again. Right, but once you remove the heat, the oxidation reduction reaction with oxygen in the air and copper, it tarnishes. Okay. So by just knowing that's an oxidation reduction reaction, it kind of helps you to prevent tarnishing or to, control it. So we need some rules to assign these oxidation states. These oxidation numbers, we're going to assign one to every single atom in a compound. Okay? So let's start with oxygen. The oxidation number of an atom we're starting with elements. The oxidation of an atom in an element is 0. So they're saying everything on the periodic table in its elemental form, like oxygen is really O2 gas, right? It's going to be 0. Iron, solid. What else is there? You could have copper, or you could have potassium, or chlorine, right? Any element that's just sitting there by itself, right, in its natural state, they're always just oxidation numbers of 0. So I'm just putting their oxidation numbers above them. Okay. The oxidation number of an atom in a monatomic ion equals the charge on the ion. So monatomic is how many? Mono is 1. So you could have like Fe plus 3. Another ion could be K plus, or N negative 3, nitride, right? So those are all examples of ions that are, monatomic. So what's their oxidation state? It's just the charge. So this one would be negative 3, a positive 1 for potassium, positive 3 for iron 3, right? So not so bad so far. Then they say oxygen, the oxidation number for oxygen is negative 2. Pretty much always in all of its compounds. So whether you have H2O, acetic acid, doesn't really matter how complicated you make or simple you make the calcium oxide, oxygen is always negative 2. So oxygen is always negative 2. And by knowing that, it helps you figure out the other guys. Oxygen is almost always negative 2. Hydrogen, it says, is positive 1. So you could have that compound, right? Whatever compound you want to write with oxygen, with hydrogen we're talking about, it's almost always positive 1. Hydrogen is. It's there, it's there, it's there. So wherever you see hydrogen, positive 1. Oxygen, negative 2. Okay. Fluorine, negative 1 all the time. What would be an example of fluorine? PF5. I don't know, I'm just making some stuff up. Fluorine is always negative 1. Right? Each fluorine atom is -1. That allows us to figure out something like phosphorus. Right? The other halogens are -1, but only in binary compounds. So I wouldn't really worry about that. The only rule I would really follow here, because you can figure that out in another way. The only rule I'd really follow here is fluorine's -1. Okay? Because now things are getting technical, and you kind of got to be careful here. The easy rules are pretty much over. Oxidation number of the atoms in a compound is, the sum of the oxidation numbers of the atoms in a compound is 0. All they're trying to say is, I don't know, let's pick this thing, H, C2, H3. You have a lot of atoms, right? You add up all their oxidation states. You better get the overall charge on what's there. So their overall charge on this compound, for example, is what? Right, their overall charge. We write it as a, we're always so lazy about this. We're supposed to be writing a 0 there all the time. Because neutral compounds are 0. But we never ever wrote it, right? That's where we write the charge. If you have like phosphate, PO4 with a -3, well, its charge is a -3, right? Because we write it. But everything else, sodium chloride, we don't write zeros. Technically, we should, because that's its charge, but we never do. So if you don't see a charge, its overall charge is 0. Otherwise, you see the charge, right? NH4 would be the charge on ammonium. What's the overall charge? Overall charge is +1. So that means nitrogen and hydrogens, add up all those oxidation states, you better get a +1, otherwise you screw it up in assigning these oxidation states. Okay? So let's try a couple of these. SO2. So Amy, we got to figure out the oxidation state of sulfur, and we got to figure out the oxidation state of oxygen. And my strong suggestion is to do what's easy first. One of them's easy. Well, it's supposed to be if you remember the rules. O is negative what? -2. Oxygen's -2. Okay. Now, the rest of this, how you figure out sulfur, you can follow my notation or kind of develop your own. What I do is I write my answers above, and then I circle them. Okay? Because you can write this big math equation, but I think it's just easier to do it this way. Because I have 2 oxygens, so my total on just do the oxygens is a -4. And I'm worried about the total because I have to add a sulfur and 2 oxygens, and I better get what?
4.
The overall charge is
0.
0. So I better add 2 oxygens and a sulfur, and I better get 0. So just on the oxygens alone, I have a -4. So what does sulfur have to be? A +4. You see that? Because I have 2 oxygens. 2 times the -2 is -4. So what plus a -4 gives me 0. So you don't need to write this out every time, but that's the game we're playing. Because, right, the overall charge on SO2 is 0. Okay, phosphate. We need to figure out phosphorus, and we need to figure out oxygen. So where would you like to start here, Monica? Where would you like to start here with phosphate? Do the easy guys first. There's no rule for the P.
No.
So the oxygen is -2. Always. Always, always, always. All right? -2. So I'm going to put the -2 up there and circle it. Okay, get you started there. Frankie, we got to figure out phosphorus. So what are you going to do to get this? Good, which is -8. Okay, so now Frankie's got us halfway there, Gilbert. you have to add phosphorus. And there's how many phosphorus atoms do I have? How many phosphorus atoms? There's just one, right? There's just one phosphorus atom. So phosphorus plus a -8 has to equal what, Gilbert? What charge on here? It's up here. Just have to read it. What's the charge on phosphate? The charge is always written as that subscript. Or sorry, it's a superscript. That's the charge, right? Everyone agree? So phosphorus and a -8 added up, you got to get a -3. So what does phosphorus have to be? Has to be 5. Do you see that, Gilbert? This has to be a +5. Because a +5, -8, give me the -3. Okay? Alyssa, what is the charge? Is there a charge on this one? On hydroxide. What's the charge? Just read it. It's a superscript. It has a little negative sign, so it's -1, right? So you want to be able to look at these guys and know exactly what the charge is. What's the charge, everybody, on F? On F, what's the charge? If you say anything, -2, you got to have a -2 up there. You have to. That's the charge. So what's the overall charge on this thing? 0. There's nothing written. 0. Pretty much on all of these, what's the charge? 0. Right? On these. Okay, let's back up here. Let's try, okay, let's do an ugly one. Let's do F. I don't think it can get any uglier than this thing. Okay? So we have to figure out what calcium is, chlorine, and oxygen. So Victoria, where do you want to start here? See if you can start with something easy. Oxygen is -2. Okay. Are there any other easy ones? Kimberly, are there any other easy ones? Now, the trick to figuring out any other easy ones is to do what we did before. Remember what we did? Like these subscripts were actually the charges, right? So what charge is actually on calcium? +2, right? This is really the charge on calcium. But remember the rule? If you have Ca +2, what's its oxidation state? +2. So calcium is a +2. So that's what I mean by the easy ones. Like Jesus, how about iron in E? What would iron have to be? +2. So those are the easy ones. Okay, so calcium's a +2. Now we got to figure out what chlorine is. Oh my goodness. Okay, Jerixa, what are you going to do?
What am I doing?
Oh. There's only one way to figure this. Well, I see 2 ways. But you're going to have to use the overall charge route, right? The overall charge on this thing is 0. 0. Don't think so hard. Overall charge is 0. So you have to add up how many calciums?
2.
I mean, how many calcium atoms?
1.
There's 1 calcium atom. How many chlorine atoms? 2. How many oxygen atoms? 8. So you have to add up 1 calcium oxidation state, 2 chlorine oxidation states, 8 oxygen states, and you better get 0. So okay, so we said calcium is what? +2. And how many calciums do I have? Just one, so okay, fine. 1 times that. Plus, how many chlorines do I have? 2. So we don't know what chlorine is, so let's just write 2Cl or 2X, whatever you like to write. Okay? Plus, what's the last one?
8.
A negative 8, right? Well, or you could be specific, right? You could say 4 times negative 2 is negative 8. Oh, but I have 2 of them. Negative 16. Ooh, I almost missed that one, right? Because we've got how many oxygens total? We don't have 4, we have 8. So 8 times a negative 2 is a negative 16. Okay, so here's your equation that you have to solve to get chlorine. Okay, so you have 2 chlorines. Let me write it down here better. Clean this up. I'm going to have 2 chlorines plus a negative 4. Well, I just added the I added the 2 to the negative 16. I get a negative 14. Right? Bring it over to the other side. I'll have 2 chlorines has to equal a positive 14. So that means chlorine has to be 7. Okay. Now there's another way to do that, but you really have to do it this way. If you do not remember, what's the charge on this polyatomic ion? This is the easier way. But if you don't know the charge, you have to do it this way. It's a negative. How do I know it's a negative? Because look at the formula. The formula tells you. Subscript on the calcium is a 1, so it has to be a negative 1. See how much easier it is doing it this way? Because chlorine, oxygen's negative 2. 4 times negative 2 is negative 8. So just by looking at it, what plus a negative 8 gives you negative 1? Positive 7. Positive 7 and a negative 8 gives you negative 1. So it's a lot easier. But the only way you can do it this way is if you know your darn polyatomic ions. That's the only way. Otherwise, don't play that game. Write it the long way and just suck it up. Right? Okay. So we'll come back and do a bunch more of these. Let's just get through this terminology. We have these reactions, and we want to get used to this redox terminology, reduction oxidation terminology. When a reactant gets oxidized, its oxidation state changes as it's being converted to the product, and it gets more positive. Reactant gets reduced, its oxidation state changes as it's getting converted to a product and becomes more negative. Okay. Reduced, more negative, oxidized, more positive. Oxidizing agents and reducing agents are always reactants. They're agents. They're the ones that are inducing this change. They're always reactants. Oxidizing agents and reducing agents are always reactants. Oxidizing agents always get reduced. Yeah, so I don't know how you guys knew that. Reducing agents always get oxidized. Okay, so let's see if we can figure one of these out. Label the oxidizing and reducing agents. Okay, now that means tin has to either be the oxidizing or reducing agent. Nitrate has to either be the oxidizing or reducing agent. We don't know which is which. There's an easy way and a hard way. Tin whose oxidation state is easier to figure out? Tin. I was just sitting there. Tin has to be what? Well, it's an element sitting there all by itself. What's its charge? If you say +4, don't you have to see a +4 right there? Yeah, there's no, I mean, there could be. I'm not saying that's a possibility, but that's not how it's written. It's written as just tin. That one's 0. Tin is 0. The reason why I'm looking at tin, because nitrates work. Why figure out nitrate? Tin is so easy. So let's just figure out tin on the other side. Tin right here. Bless you, Christine. So Jesus, what would you do first to figure out tin on the product side? Oxygen's always what? We said oxygen is always -2. Each oxygen is -2. So by looking at this, Amy, what's tin have to be on that side? She says +2. If it's +2, a positive, how many oxygens do we have? 2, -4. Doesn't quite work. +2 and a -4 is -2. So it can't be +2. So I guess don't skip. I guess I'm trying to get you to do, Amy, is don't skip this. You actually have -4 on that side. So tin has to be +4. Excellent. Tin has to be +4. Okay. So tin it went from 0. So tin went from 0 to +4. So tin got oxidized or reduced? Oxidized. This is the only way I can do this. Otherwise, I screw it up every time. You go through all this work, you don't want to make a silly mistake. Tin got oxidized, so tin is the blank agent. Reducing agent is opposite. Tin got oxidized, so it is the reducing agent. And nitrate then is the oxidizing agent. Okay? Let's try one more of these, then we'll go back and do some more of the other kind. Let's jump down to C, though. The reason why I would jump down to C is because, Monica, there's an easy way and a hard way to figure this out, right? We know that either, for example, this compound is either the oxidizing or reducing agent. Same with this guy. He's either the oxidizing or reducing agent. But there's one compound that's a lot easier to work with than the other one. Chromium. Chromium is the easy one to work with. Why? It's all by itself on the product side. So it's half of the work is done for you. So chromium is going to end up with what oxidation state? +3. Chromium is going to end up at +3. So let's just figure out what chromium is in its compound on the reactant side, and then we can figure it out. So Christine, what would you do first here to figure out chromium on the reactant side? Start with what you know. And it's almost always the oxygens. They're always what? -2. They're always -2. They're always -2. Okay? Now what'd you do, Frankie? Exactly. You end up with a -14. Okay. Now you gotta look at this close, Gilbert. How many chromiums do we have? How many chromiums do we have in this compound? How many chromium atoms? 2. So 2 times chromium and a -14 had better give me what overall charge, everybody? -2. So what does each chromium have to be? I don't know. I can't do jack in my head, so I got to actually work it out. 2, just test it. 2 times a +6 is a +12. A +12 and a -14 is -2, so it works. I would check it out because it's too easy to screw up in your head. So chromium's +6. So Cr2O7, -2, got, Lauren, what did it do? It went from a 6 to a 3. It got reduced. So this compound is the blank agent. It is the, everybody? Oxidizing agent. Excellent. And what is the reducing agent then? Yeah, just copy it. H3ASO3. Arsenic. Oh, it's some arsenic acid some kind. Okay? Okay with that? So let's go back up to where life is crazy. Right? Let's try some of these. Okay? So you work them out, and then in about 5 minutes I'll ask you for some answers here. Okay? And if you're not sure how to do something, just ask. Start out with what's easy, right? And usually there's 2 easy ones. The oxygen and then something else.
Okay, so this starts off in 0.
Yes, the overall charge is 0. Okay, yeah, good. K has to be +1, right? So write that. So K is +1, oxygen's -2. Yeah. Well, so you have to, I would write it on here, Jerix, just like I was doing. A little +1, a little -2, so then you can do the math. Right? So Christina, you see what's going on here? Okay, -6. Now the K, that's the one where, what does his charge have to be? If you broke this up in those, like those ionic equations that we did last time, you'd break it up into carbonate, which is CO3 -2, and then 2, and each one has a what charge? +1. So those are your 2 easy ones. O is a -2, K is a +1. And then you go and do this. Well, yeah, but write K equals +1. O equals -2. Right? And write a little +1 up here. And then you can do the math. So did you figure out the 2 easy ones for this one? You have to know K, C, and O. O is always -2. That's an easy one. But the other easy one was that potassium. He's supposed to be an easy one. Because if you broke him up, right, in the ionic equation, you would say 2K plus carbonate, right? But you don't, that's going way too far. You don't need to do all that. But you can look at this formula. There's a 1 right down there. This has to be a +1. And it's in group 1 too. That's another hint. K +1. So K is your other easy one. Before you do any math, you got to figure out 2 of those. Because if you write an equation, there can only be 1 unknown in it. So there's always going to be 2 easy ones. Now you write the math equation or figure it out. Okay? Figure out what C is. Anybody get an answer? I hear a 4, a 6. Okay. 3 times -2 is -6. Now I have 2 potassiums. It has to be a +2. How many carbons do I have? Just 1. So what +2 and a -6 gives me 0. +4. Yeah. If you said 4, you nailed it. Okay.
So how come this one is dividing this?
Because our equation was more ugly. We did it. We did it here too. We did it here too. You just screwed up on your math. You screwed up on your math. Right?
What did I do? It's 6, empty. And then I put the 6 in.
I'm not sure how you're writing your math here. I don't see an equation. So I would write it over the top of this. 3 times negative 2 is negative 6. 2 times positive 1 is positive 2.
Yeah.
Okay. So positive 2.
This one and put it on this.
Okay, so that's a 6. Subtract 2.
So subtract 2. Okay, I just
Right.
divided it.
No. H is ugly, but really not too bad. You can do it. Again, there's 2 easy ones that they're supposed to be easy ones in H, lithium thiosulfate. Victoria, how did you do H? What did you list as your easy ones that you nailed right away?
Oxygen.
Okay, it's a negative 2, right?
And lithium.
Is what?
Positive 1.
Positive 1. Now, how did you figure out lithium's positive 1?
Because
It's in group 1. Strong hint. The other strong hint is this whole thing, subscript 1. He has to be, right? This charge positive 1. Okay? And then, Shelby, what did you get for sulfur in H as a final answer? Positive 2? Anybody else get a positive 2? Yeah? Great. All right, keep going. I'll just work it out so in case someone didn't. Yeah. So if anyone's lost on this, just ask. I can help you out. Oh, each O is always negative 2. Its total's negative 4. You're right, but each oxygen's negative 2. So in our answers, and they want to know what the oxidation states are, they're these, right? Does this make sense, Gilbert?
No.
Okay.
I just have to.
3 times negative 2 is negative 6.
I don't even know what I'm trying to do.
You're trying to add up all of these. You have 2 lithiums, 2 sulfurs, and 3 oxygens. You have to add up all those numbers, and you better get 0. And you get 0 because there's nothing written there. It's neutral.
So I want 0 here, here.
All of them have to add up to be 0 because there's no charge written on any of these. Now, like on this one, this has a negative 1. An O and an H better add up to be negative 1. This one has a negative 3. A P and 4 O's better add up to be negative 3. So it just depends on what they write as the charge. Here's the 0, 0, 0, 0. That helps? Getting these? Yeah, perfect. Getting it to work? Yeah, good. Strontium's a +2. That's supposed to be the easy one. Yep.
6 or -12.
Yeah. Looks right.
So
Yep.
-10.
You got it. You got it. Very good, Jesus. So you have to add, so a +2.
So this is +1.
Yeah, but you have two of them though. So you have to add a +2 and a -6, and then 2 sulfurs, and you'll have to get 0. Because you have 2 sulfurs.
So what's the point of this +1?
Because that's the answer for lithium. But you have 2 of them. So you have to add up 2 lithiums. So you have to add +1, +1, a -2, 3 times. So it's easier just to, instead of saying +1, +1, just multiply. 2 times +1 is +2. 3 times -2 is -6. You're right, these are your answers down here. So I would circle. Those are your answers. But now you got to figure out what sulfur is. The only way to do it is to do the total. So +2, -6, and then, and this has to, +2, -6, plus 2 s's, 2 times x, has to equal 0. All that has to equal 0. Yeah, you don't know what that one is. That's question mark. And that has to equal 0. So you bring the 6 over. Yeah, so bring the 6 over, that'd be a -6. Sorry, that'd be a +6, right? Subtract 2 would be a +4. Divide it by 2, you get 2. Mm-hmm. All right, let's try that one. Monica's wondering about this one. So on this one, there's 2 easy ones. Always -2 for oxygen. But strontium is what? +2. Right? And you know it because of that. There's this charge right there. Then you can figure out what the iodine is. Right? So I've got a -2 here, but I have 6 oxygens. So I have a -12. And the strontium is a +2. And I'm circling my answers there, but so the total for the strontium is a +2. But I have 2 iodines. So the question, the math equation you're writing here is +2 plus 2 i's, and a -12 has to be 0. Or x, whatever you want to use for your variable. +2 plus 2 of my iodides plus a -12 has to be 0. So what, you get 5 out of that? Okay. Here, -2, +4. Okay. So come by 11 to 1 today, or, right? Pretty much any time on Thursday. Be here all day. Just come by so I can help you out.